Hello everyone, Mosh here. So, have you ever tried to organize a massive collection of photos, music, or even your favorite recipes? It can get messy, right? You might stuff everything into folders, but finding that one specific photo of your cat wearing a tiny hat becomes a total nightmare. Think of a database as the ultimate super organized digital librarian for all your data. And one of the most popular, powerful, and friendly librarians out there is named PostgreSQL. It's an open-source relational database management system, which is a very long and fancy way of saying it's a brilliant tool for storing and retrieving data in a structured way. So, why do so many developers love PostgreSQL? Well, it's not just powerful, it's also incredibly reliable and flexible. Companies like Netflix, Instagram, and Spotify use it to manage massive amounts of information, from your viewing history to your carefully curated playlists. It's the silent engine behind countless websites, mobile applications, and complex data analytics systems. It's known for being a do-it-all database that handles everything from small hobby projects to enterprise-level applications with grace. The best part? It's completely free. You get all this incredible power without spending a single dollar. It's a fantastic choice for anyone starting their journey into the world of data. Getting started is easier than you think. To install PostgreSQL on your computer, you can head over to its official website and download the installer for your operating system, whether it's Windows, Mac OS, or Linux. The installer usually bundles a fantastic graphical tool called pgadmin. Think of pgadmin as a friendly visual dashboard for your database, where you can click around to see your tables, run queries, and manage everything without typing complex commands. For those who love the command line, PostgreSQL also comes with a tool called PSQL. This is a powerful terminal-based interface that lets you interact with your database directly by typing commands, making you feel like a true coding wizard. Once installed, the setup process will ask you to create a password for the main database user, which is typically named Postgres. Remember this password. It's the key to your entire database kingdom. After that, you're ready to go. You can open pgadmin, connect to your local server, and start creating your very first database. It might feel a little intimidating at first, seeing all the buttons and options, but don't worry, we're going to break it down piece by piece. Your journey to becoming a database master has officially begun, and it's going to be a lot of fun. Let's dive in and see what makes this system tick. Alright, let's build our mental model. At the highest level, you have a database. Imagine a giant digital filing cabinet. You might have one cabinet for your music collection and another for your movie library. Inside this cabinet, you have folders, and these folders are called tables. For our music collection, we might have a table for artists and another for albums. It's a way to keep related information neatly separated and organized. Each table is designed to hold a specific type of information, preventing our data from becoming a jumbled mess. It's all about structure and order. Inside each table, we have rows and columns. Think of a table as a spreadsheet. The columns are the headers at the top, like artist name, genre, and year formed. They define what kind of information we want to store for each entry. The rows are the actual entries themselves. So one row in our artist table might be Queen, rock, and 1970. Another row could be Daft Punk, electronic, and 1993. Each row is a unique record, a single item in our collection, described by the data in its columns. This simple row and column structure is the fundamental building block of all relational databases. Now, how do we actually interact with this data? We use a set of fundamental operations known by the cool acronym CRUD: create, read, update, and delete. Create is how we add new data. For example, we'd use a SQL insert statement to add a new artist to our table. Read is how we retrieve data, which is done with the select statement. We could say, select all artists from the rock genre. This is arguably the most common operation you'll perform. Update lets us modify existing data, using the update statement to say, change an artist's genre. And finally, delete removes data using the delete statement, which we'd use if we wanted to remove an artist from our collection. These four CRUD operations are the bread and butter of database management. Every complex application, at its core, is just performing these simple actions over and over again. To make sure our data is stored correctly, PostgreSQL uses specific data types for each column. You can't just throw anything you want in there. For a column like artist name, you'd use a text or varchar type. For year formed, you'd use an integer, which is just a whole number. For a release date, you'd use a date or timestamp. Using the right data type ensures data integrity, like making sure you can't put the word banana in a column meant for numbers. Okay, so we have an artists table and an albums table, but how do we know which albums belong to which artist? This is where the magic of relationships and joins comes in. We create a link between the tables. In our albums table, we would add a column called artist.id. This column would store the unique ID of the artist from the artist table. This connection is called a relationship. Now, when we want to see all the albums by Queen, we can perform a join. A join is a SQL instruction that combines rows from two or more tables based on a related column between them. This ability to link related data is what makes relational databases so incredibly powerful. Instead of duplicating the artist's name for every single album, we store it once in the artist table and simply reference it. This saves space and, more importantly, prevents inconsistencies. If you need to update an artist's name, you only have to change it in one place, and the change is automatically reflected everywhere. Think of it like a Venn diagram, where the join operation finds the overlapping connected information between two sets of data, giving you a complete, unified view. It's the cornerstone of designing clean, efficient, and scalable databases. To make finding data super fast, we use indexes. Imagine trying to find a topic in a huge textbook without an index at the back. You'd have to scan every single page. A database index works the same way. It's a special lookup table that the database search engine can use to find records much, much faster. When you frequently search for artists by their name, you can create an index on the artist name column. The database then maintains a sorted list of names, allowing it to jump directly to the data you need instead of scanning the entire table. Indexes are a crucial tool for optimizing database performance. To protect our data's integrity, we use constraints. Constraints are rules you set on your columns to prevent bad data from being entered. For example, a not null constraint ensures that a column cannot be empty. A unique constraint guarantees that every value in a column is different from all other values, perfect for an email column where you don't want duplicate accounts. Think of constraints as the traffic rules for your data highway. They ensure everything flows smoothly and predictably. We can also use simple views, functions, and triggers. A view is like a saved query that you can treat as a virtual table. A function is a small, reusable piece of code. And a trigger is an automatic action that happens when data is changed, like an alarm that goes off when a record is deleted. So, how do you actually talk to your PostgreSQL database? You have two main options: a graphical user interface, or GUI, like pgadmin, or a command line interface, or CLI, like PSQL. For beginners, pgadmin is fantastic. It gives you a visual representation of your servers, databases, and tables in a tree-like structure on the left side of the screen. You can right-click to create a new table, use a friendly interface to add columns and set data types, and even view the data in a spreadsheet-like grid. It also includes a powerful query tool where you can type your SQL commands and see the results instantly. It's a great way to explore and learn without the pressure of memorizing every command. On the other hand, many experienced developers prefer using PSQL. It's a terminal-based tool that you access directly from your command prompt or terminal. While it might look intimidating with its blinking cursor, it's incredibly fast and powerful once you get the hang of it. You can type SQL queries directly, run scripts, and manage your database with a series of simple / commands, like \L to list databases or \DT to list tables. Working in PSQL can make you feel like a character in the Matrix, efficiently manipulating data with just a few keystrokes. Both tools are excellent. Which one you use often comes down to personal preference. A database isn't very useful on its own. Its real power is unleashed when you connect it to an application. Whether you're building a website with Node.js, a web app with Python, or a mobile app with another language, you'll need a way for your code to communicate with PostgreSQL. This is done using a database driver or a library. For example, in a Python application, you might use a library like psycopg2. This library acts as a translator, allowing your Python code to send SQL queries to the PostgreSQL server and receive the results back. Your application can then take that data and display it to a user, save new information, or perform complex business logic. So, you've taken your first steps. What's next on your learning roadmap? First, get comfortable with the basics. Practice your CRUD operations. Select, insert, update, and delete. Then, dive deeper into designing tables and understanding relationships. Mastering joins is a huge milestone. After that, you can explore more advanced topics like indexes for performance tuning, writing complex queries with subqueries and aggregate functions like count and sum, and understanding transactions to ensure data safety. The world of databases is vast, but you've built a solid foundation. Keep practicing, stay curious, and you'll be a PostgreSQL pro in no time. Happy coding!